Wait a couple more minutes. See if a few more people arrive.
Good morning.
Good morning. All right, we'll roll with it. So we're on page 137. We're going to factor the following polynomials using the greatest common factor, GCF, or grouping method. So if we look at this guy here on number 9, there's x's, there's y's, and then there's coefficients. We see 3's and 6's. One thing we could do is we could pull a 3 out of everything, right? But everything doesn't have an x, and everything doesn't have a y. Let's see, let's just pull a 3. Since everything has a 3, let's pull that 3 out. So we need a 2x squared. A 3 times a 2 is a 6x squared. Minus xy, so we have our 3xy. And a 2x. 3 times 2 is 6. So we got this 3. I'm going to use these square brackets here. See, this thing here, it has x squareds in it. All right, they don't have a y. Let's pull an x squared out of that. So we got an x squared times y. All right, we got a minus 2. See, x squared times a negative 2. This is our negative 2 x squared. And then we still got this over here left. So both of those have an x in it. So if we pull out, let's pull out a negative x. So you have a negative x times a y. And then get this 2x, I'd have to have a minus 2 here. A negative x times a negative 2 is a positive 2x. So we still got this 3. Notice I got these square brackets, right? Because this 3 is getting multiplied into everything in here. But notice we have this x squared and a negative x. They're both being multiplied by y minus 2. So we got an x squared and a negative x, both being multiplied by a y minus 2. Okay. At this point, we don't have to have these square brackets anymore. All right. So that would be our greatest common factor or grouping method. All right. So you can always check your work, right? You can multiply the stuff back through. All right. We have this. We multiply the 3 in, we'd have a 3x squared minus 3x. See if we brought that 3 inside this factor here. So that's our factoring. We're checking our work here. Now if we multiply this across, we'd have to do this one and that one, and then this one and that one, which would give us, we'd have the 3x squared times a y, and then 3x squared times a negative 2. That gives us a negative 6x x squared. This one gives us a negative 3xy. And that one gives us a positive 6x. So if you look up here, there's that term, that term, that term, and that term. So that was a good factoring. All right, we checked our work. I'm gonna put it pink. Any questions about this?
No, sir.
All right. If you haven't done factoring before, you're gonna have to practice a lot. It can get kind of hairy. All right, so for this one, let's see. Let's just leave the numbers alone right now. Let's just focus on the x's and pull out what numbers we can. If we look at these first two, they both have an x, but these two don't have anything in common. What if we rearrange this? Let's put this one over here. And let's put the 9x y over here. Because at least these two have y's in them, you know? Because these right here, there's nothing they have in common. There's not a lot we can factor out of both of them, except for maybe a 2, you know? So if we look at these, we can at least get, what, a 10 out of there? And an x. We'd have to have a 3x. 10x times 3x is 30x squared. And then this 20x, we would get a 2. 10x times negative 2 is a negative 20x. If we look at this guy, let's see, if we pulled out a 3y, we would still have to have a 3x. 3 times 3 is 9, and then an x times a y. And then for our 6y, we'd have to have a minus 2. 3y times a minus 2 is a minus 6y. And conveniently, we have the same factor here. So what this is we have a 10x, and we have a 3y. They're both being multiplied by a 3x minus 2. So that is our factoring. And we can check our work, right? You can do the FOIL method if you want, but I don't like saying FOIL because it only works when there's 2 things times 2 things. So we have, okay, hold on, puppy. Come here. Oh, Miley wants to say hello. Show off her giant paws. Good girl. Babysitting for one more day. So 10x times a 3x gives us a, calm down, 30x squared. The 10x times a negative 2 gives us a negative 20x. The 3y times the 3x gives us a 9, an x and a y. The 3y times a negative 2 gives us a negative 6y. So if we look up here, we have all of our terms. So yeah, that was a good factoring. It's number 10. All right, for number 11, let's see, what do we got? These both have x's. These don't have x's and y's. We might have to rearrange these again. to see at least these two have y's together. So we just rearrange these. And now let's look at these two groups to see 56 and 70. All right, what number can we pull out? What number can we pull out of a 56 and a 70? Like a 7 maybe? What is 8 times 7? Anybody remember? Early in the morning. Yeah, 8 times 7 is a 56, and a 10 times 7 is 70. So let's see, if we pulled out a 7, right? We would end up with an 8 minus 10, right? But these are both divisible by 2. So if I pulled out a 14, I would have 4 minus 5, right? So 56 and 70 are both divisible by 14. So let's pull out a 14 and an x and see what happens. This would leave us with a 4x minus 5. All right, that gives us 56x squared. And that gives us a 70x. So over here, what we want to do is pull something out where we end up with this same factor. That's the goal, right? So if we want to end up with a 4x minus 5, since both of these have y's, we're going to have to pull a y out. And to get this 4x, we'd have to have a 6, right? 6 times 4 is a 24, and a 6 times a negative 5 is negative 30. So, see, if we factored it differently, if we, instead of pulling out a 6, we pulled out some other number, then we wouldn't have a 4x minus 5 here. We would something else, and we wouldn't be able to factor both of these things nicely. So as is, we got a 14x and a 6y. They're both being multiplied by 4x minus 5. Not all the problems like work out on our first guess, you know what I mean? These have been pretty easy because we just kind of looked at the x and y's and it happened to work out. Not all of them work out all nice. You end up with ugly numbers and then they don't fit. But there's tricks to make it fit. All right, this one, those both have the y's. I don't know, these both have x's, but we can't just leave this guy stranded. We kind of have to get them into pairs, right? So maybe if we pair those up, if we leave it as an xy minus 10y, then a 12x minus 15. These have the y's. If we pull the y's out, we're going to end up with an x minus something. Over here, we're going to have an x minus something. So let's see, if we pull out a 2y out of the first two terms, that'll give us 4x minus 5 again. And over here, again, we want to get a 4x minus 5, right? And luckily, this works out where we can get a 4x minus 5. If we have a 3 here, 3 times 4 is a 12x, and a 3 times negative 5 is negative 15. So we have a 2y and a 3, and they're both being multiplied by 4x minus 5. All right, we could check our work. 8xy minus 10y plus a 12x minus 15. There's a 12x, or minus 10y, or 8xy, and a minus 15. So that worked out. 12. All right, we're on page 138. Factor the trinomials completely. They don't tell us any method to use. All right. When you have, notice there's not 4 terms here, there's just 3. When you have a quadratic, you can always rewrite it something like this. P plus Q, Q plus X times a P plus L. Doesn't matter what the letters are. Something plus something times something plus something. These are 2 binomials multiplied together. So if we're looking at this, all right, we need to find 2 factors that multiply together to give us this. So just eyeballing it, we can tell we need an x times an x to give us this x squared, right? Nice. And we need 2 numbers that multiply together to give us an 8, right? We have an 8 times a 1 or 2 times a 4, right? But these numbers have to add to give us this negative 6x, right? If I put a 2 and a 4 in here, and let's say I put a plus and a plus, that gives me an 8, right? But I'm going to get a 2x and a 4x, and they're going to add together to give me a positive 6x. I need a negative 6x. So that tells me that these can't be positive. But if they're both negative, a negative 2 times a negative 4 gives me a positive 8. And I got a negative 2x and a negative 4x that add together to give me the negative 6x. Y'all see that? So whenever you have trinomials like this, if they're nice to you, you can look for 2 numbers that multiply to give you this, that add to give you that. All right? This was one of the easier ones. Let's look at this one. And there's no number in front of the x squared, so we know we need an x and an x. Okay. And as far as 15 here goes, we're lucky there's a 14 here, because 15 times 1 gives us a 15, right? And if I make this one negative and that one positive, I got a negative 15x and a positive x. When I add those together, I get the negative 14x. Okay, so you have to pay attention to which one's positive and which one's negative. If I switch the positive and negative here, it wouldn't work out. I would end up with a positive 14x. Does that make sense, y'all? All right, you can always check your work. X times an x is an x squared. Got a plus an x, minus 15x, minus 15. These 2 give us this negative 14x that we were looking for in the middle. Okay. All right, not all of them are like this where you can just look at it and write it down. Sometimes there are no two numbers you can multiply to give you a 28 that add to give you a 3. In this case, 28 though is 7 times 4, and the difference between 7 and 4 is 3. So this is going to work out where we can just write it down. If we have a 7 and a 4, 7 times 4 will give us the 28, but one of these has to be negative and one has to be positive. Since we want to have a positive 3, we want the 7 to be positive and the 4 to be negative. See, this gives us a negative 4x, but a positive 7x will add to give us a 3x. Here we know we can do this one because a 3 times a 3 is going to give us a 9. And they can, if they're both negative, they'll add to give us a negative 6. So if I have a negative 3 and a negative 3, they multiply to give me a positive 9. And I'm going to get a negative 3x and another negative 3x, which will give me a total of negative 6x. This one, we can look at a 5 and a 2, right? 5 times 2 gives us 10, and 5 minus 2 is 3. So if we have our x and our x, and a 5 and a 2, we need to get a negative 10, so one of these has to be negative and one has to be positive. Since we want a positive 3x, we need to make the 5 positive and the 2 negative. So we get a negative 2x and a positive 5x that are going to give us a 3x here. This one should be easy because a 5 and a 3 give us 15, right? And 5 minus 3 is 2. We have an x, a 5, and a 3. We want to get a negative 15. One has to be negative, one has to be positive. We want to get a negative 2x, so we need to make the 5 negative and the 3 positive. We have a negative 5x, positive 3x. That gives us a total of negative 2x. Here's another way that you can do these problems. What if you were considering the equation, this thing equals 0, right? If you've used the quadratic formula to find the solutions, right? We just did the factoring. What if this was equal to 0, right? What would the solutions be? The solutions would be 5 and negative 3. Because if I put a 5 right here and a 5 right here, this is 0, and 0 times 0 is 0. If I put a negative 3 in for x, this is 0, and 0 times 0 is 0. All right, so another way to solve these, to find the factors, you can use the quadratic formula to find the solutions. Once you have the solutions, you can write down the factors. So if you can't guess which numbers to put here, you can always use the quadratic formula. So check it out. Okay, A is 1, B is negative 2, and C is negative 15. So our solutions, that was equal to 0, would be a negative B plus or minus the square root B squared minus 4AC all over 2A. So the negative 2 would be a positive 2. 2 over 2 is 1. Got a 4. Negative, negative is plus. 4 times 15 is 60. We got 1 plus or minus square root of 64 over 2. Square root of 64 is 8. We got 1 plus or minus 8 over 2 is 4. So 1 plus 4 is 5, and 1 minus 4 is negative 3. So if those are our solutions, then our factorization, all right, is going to be x minus each solution, 5 and a negative 3, right? So a negative negative here is the same as plus. All right, so that's another way to find your factors, is to use the quadratic formula, because not all of them are nice where you can just look at it and see, oh, here's 2 numbers that multiply to give us this and add to give us that. They don't always work out that way. Sometimes they're just really ugly. So if you have something like 0.089x squared minus 764x plus 17.89, how are you supposed to factor that, right? Well, you can always use the quadratic formula, and it'll tell you the solutions. All right, and we'll do examples kind of like that. We won't use such ugly numbers. We'll use numbers just ugly enough to where you can't just look at it and guess the factors. So like this one. Notice there's a 7 here. And so that's going to complicate things when we try to just guess what our factors are. If there's a number out front here, it makes things a lot more difficult. So what we're going to do, in this case, everything happens to be divisible by 7. All right. So now we just look at this. So this one is just one step away from simple, right? If we pull that 7 out, now we can factor this other guy here. Because like we got a 5, right? And a 5 times 1 is 5, but a 5 plus 1 is 6. So if we have an x and an x, and a 5 and a 1, and they're both negative to give us a negative 5x, and a negative x gives us our negative 6x. So that's our factorization. This one's similar. At least all the numbers are divisible by 3, right? So now that we've pulled the 3 out, maybe we can factor this thing easily. All right, to get a 12 and a 1 won't give us a 2. We'd need like a, let's see, what can we use? 4 and a 3. 4 and a 3 won't work either. Right, think about it. If we had a 4 and a 3, one's positive, one's negative, this gives us a 4x minus 3x, right? That would add up to a positive
1x.
But we got 2x, right? So the 4 and the 3 aren't going to work, right? If we tried a 6 and a 2, that would either give us 8x or 4x, right? So this one just isn't one where you can just eyeball it, is it? So what we can do here is we can use the quadratic formula on this guy. All right. If A is 1, B is 2, and C is negative 12. All right. Just looking at this piece right here, let's find out what the solutions would be. And then we know what the factors are. So we'd have negative B plus or minus the square root of B squared minus 4AC all over 2A. So negative 2 over 2 would be a negative 1. 2 squared is 4. Negative negative is a positive. 12 times 4 is 48. So 48 and 4 is 52. It's the square root of 52. I don't think that is a nice number. Yeah, the square root of 52 sucks. Let's see. 52 is 2 times what? 26. And 26 is 2 times 13. So the best we can rewrite this thing is negative 1 plus or minus. Let's see, we could pull 2 out. This is square root of 4 times 26 over 2. Square root of 4 is 2. We got root 26 over 2. So we got negative 1 plus or minus the square root of 26. Oh, what the hell? They were thinking. Where are we? Down here? So to factor this thing, you can't really factor it nicely, right? Our factors would be x minus and x minus are two solutions. We'd have a negative 1 plus the square root of 26 and a negative 1 minus the square root of 26. That would be our factorization. Okay. You know, unless I did something wrong in my arithmetic here. Let's check it real quick. A is 1, B is 2, C is negative 12. Negative B plus or minus B squared minus 4AC all over 2A. So negative 2 over 2 is a negative 1 plus or minus. 2 squared is 4. A minus minus is a plus. 12 times 4 is 48. I got the square root of 52. 52. Okay, yeah, I did something wrong here. 52 is not 4 times 26. 52.
Isn't it 2 times 20?
Yeah, it's 2 times 26, right? Which would be 2 times 2 times 13. So the 2 times a 2 would give me a 2 square root of 13, which isn't any prettier, right? I'd still have a square root of 13 in here. So this just isn't factorable. We just leave it like that. Sorry, like this. Wait a minute, wrong problem. Like that.
No, it's the other one.
This one, right? Yeah, so you can't do anything other than pull a 3 out of there. Not a lot you can do. There is another approach that we can try. All right, a grouping method. Okay, what we can do is we can try to rewrite this as like, instead of plus 2x, maybe we could do a plus an x plus an x. All right, and then factor something out, like group these and group these. So, but there's other options, not just plus an x, as long as they add together to give us a 2. Like what if we put plus, let's see, what if we did like plus 3x minus x? All right, or we could do plus 5x minus 3x. All right, what if we wrote it like that? Then these, we could pull an x out and we get an x plus a 5. But over here, if I pulled out a -3, I'd have an x plus a 4. See how these are almost the same, but not quite? So what we need to do is we need to take this middle term and we need to figure out how to rewrite it so that we get the right terms. And it turns out that what you want to do is you want to look at this middle term here. All right, this is our b, right? Remember, here's our a and our c. If we look at our a times our c, that's 1 times -12, right? -12. We're looking for two numbers that if we multiply them together, we get -12, but they add to give us a 2, right? Let's see. Yeah, I can't think of two numbers though. 6 and 2. Yeah, this just isn't factorable. All right, we're stuck here. All right, some of the problems you can work it out, but ultimately these, if we're going to factor it, this is what the factors are going to look like. So there's nothing we can do. The quadratic formula says it all for us. All right. But the ones where the quadratic formula does pan out, we'll use this other simpler method here. So let's see here. We're on page 139. Let's look at this one. So this one, we have this number up front, right? Makes things more complicated. So if we're just going to try to eyeball it, we can't just have an x and an x, right? We'd have to have like a 6x and an x. Or we'd have to have like a 3x and a 2x, right? It's got to be one way or the other. And then for this -2 over here, we're going to have a 2 and a 1, right? And then we have to put in either a plus or a minus and keep checking our work. So that's what we're going to do instead of trying to guess it. All right, let's use this other method. We got an a is a 6, c is -2, a times c is -12. All right, our b is 1. We are looking for two numbers that multiply to give us this, right? We're looking for numbers p and q that give us a -12, but p plus q gives us a 1.
4 and negative 3.
4 and
4 and negative 3, right? Yeah, so what we're going to do is we're going to rewrite this to be a plus 4x minus 3x. Actually, we're going to write it the other way. Minus 3x and a plus 4x. All right, because when we do that, we can group these into two separate groups. It allows it to work out. If we pull a 3x out of the first two, hold on. Hey, go outside with that. All right, come on, come on. Come on, go play. Go on, yeah, keep going. Go, 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 go. Yeah, doggies. And you too, kitty cat. This is a farm in here. Okay, where were we? Oh, 3x times a 2x gives us a 6x squared, and then a minus 1. 3x times a minus 1 is a minus 3x. Now this guy over here, we could pull out a 2, right? And that gives us a 2x minus 1. So using this little trick over here, we end up with both factors 2x minus 1. So this gives us 3x and a 2, both being multiplied by a 2x minus 1. So that's the trick. You look at a times c, and you're looking for two numbers who multiply the same way a times c does. They give you whatever a times c is, but they have to add to give us b. So you want a p and q, you want a p times a q that's equal to an a times a c, and p plus q is equal to b. Those are the two conditions. All right, and this works out. Now, I had to look this up. I taught the last class because I didn't remember this from, I don't know, 25 years ago. You know, when I look at any problem, I know the quadratic formula will work. So what I did, all right, before I figured that out, I did it the long way. I pull a 6 out, and I get x squared plus 1/6 x, and minus 2/6 is a 1/3, right? 6 times a 1/3 is 2, right? So a is 1, b is 1/6, and c is negative 1/3. And so I'd find my, I'd set that equal to 0, find my solutions. X would be negative b plus or minus b squared minus 4ac all over 2a. So 1/6 over 2 is a negative 1/12, plus or minus square root of 1 over 36. Minus minus is a plus, what, a 4/3. And in order to get a common denominator in here, I'd multiply this by a 12 over a 12, all over 2. So I get a negative 1/12 plus or minus. All right, 4 times 12 is a 48, plus 1 is a 49 over 36. Square root of 49 is 7. Square root of 36 is 6. It's not 12. 7/6 divided by 2 is 7/12. So my two answers would be negative 1/12 plus 7/12, which would be 6/12, and negative 1 minus 7 would be negative 8/12. 6/12 is a half, and negative 8/12 is Dividing them 4, negative 2/3. So that would tell me that this thing, right, this is 6 times, my factors would be an x minus a half, and x minus a negative 2/3, or positive 2/3. So the answer we got up here in just a couple of steps, right? All right, looks different than the factors I have. But if you rewrite this 6 as a 2 times a 3, right, times this stuff, if I bring the 2 into here, right, into the first term, I get a 2x minus 1. If I bring the 3 in over here, I get a 3x plus 2. So they are equal. All right. So the other approach is to use the quadratic formula. Again, this little trick here where we're looking for two numbers that multiply to give us a times c and they add to give us b. Not all the problems work out that way. There aren't necessarily a p and a q that add to give you b and multiply to give you a times c. So if this trick works, you can get it real quick like this. If it doesn't, the only way to factor it is using the quadratic formula. So let's look at another one here. Let's see if this trick works, right? So we got a lot of numbers here. Our a and our c. A times c here is 8 times 5 is 40. All right. B here is negative 14. So we're looking for a P and a Q where their product is 40, but their sum is negative 14. So what about a 10 and a 4, right? 10 times 4 is 40. Well, we need a negative 10 and a negative 4, right? Because then we get 40, right? And they add to give us a negative 14. So if we rewrite this as a negative 10x and a minus 4x, all right, then we can group. We can pull a 5x out of this. That gives us an x minus 2. And we can pull a 4 out of this, x minus 2, right? Negative 4 times a negative 2 is a positive 8. So since these are both being multiplied by an x minus 2, we have a 5x and a negative 4 both being multiplied by an x minus 2. All right, let's take a 10-minute break. 50 minutes is about the longest amount of time you can study without getting burned out. So we'll come back at 10 o'clock.
Yes, sir.
So we're on number 22. So we're number 23 here. Come on, computer. Don't give up on me. My computer needs a second to catch up. My pen just died. Hold on 1 second. For some reason, my pen just died. My mouse works, but I can't write with my mouse very well. There it goes. Oh, maybe not. It works in everything else. Hold on a second. Maybe if I close this. Yeah, it's working with this, which is fine. Alright. That size. There we go. Pin functionality back. Alright. So if we're trying to factor this guy, let's see. Our A times our C is -90. So we need a P and a Q that multiply to give us -90. Our B is 9. So we need our P plus Q to give us 9. So let's see, for -90, what if we did a P to be a 10 and a Q to be a negative that won't work. To give us -90. Hold on. We need to multiply to get to 10 and no, that won't work. All right, that gives us a -90, but they're adding to give us a 1 instead of a 9. Let's see, what can we multiply to give us 90? Let's see. Any ideas? What is like 90 divided by like 15? 90 divided by 15.
Is it 6?
15 and 6. That would work, right? If we had a 15 and a -6, they multiply to give us -90, right?
Yes, sir.
And they add to give us 9.
Yes, sir.
So we can rewrite this guy as -6x plus 15x minus 10. I put the 6 first to go with the 9 and the 15 to go with the 10 over here. So this first one, if we pull out a 3x, we got a 3x minus 2. That gives us a 6x. And then we pull out, what, a 5? We get a 3x minus 2 again. So we got a 3x and a 5, both times a 3x minus 2. All right. So again, if that hadn't worked out, we'd had to resort to using the quadratic formula to finding the factors. Okay. Let's look at number 24. All right, let's see our A times C, 9 times 7, is that 63, is that right? I can't remember my elementary school math. Yeah. So we need a P and a Q that multiply to give us a -63. B is 16. So they need to add to give us 16, right? Which looks like 9 and 7 would work, right? 9 and 7 add. So P is Well, they have to give us a positive 16, right? I'm not sure how they're gonna. I mean, if we multiply them, they got to give us a negative 63. So one would have to be positive and one have to be negative, right?
Yes, sir.
And see if we did a 9 and 7, that's going to give us a positive 63. Yeah, they'd add to be 16, so that won't work out. So 9 and 7 aren't going to work. What else can we divide 63 by, huh? 63 divided by 3. 21, right? 21 times 3. But they won't add to give us 16, will they?
Wouldn't it be considered not factorable?
Yeah, if we can't figure it out, right? But I mean, we can factor it using the quadratic formula. Factors are just might be ugly, right? If we rewrite this
Yes,
as a
sir.
7 times an x squared plus 6, well, we can factor it as is probably. We do a 16 over 7 minus a 9 over 7. If we factor this ugly guy, all right, I guess we could leave the 7 in there. See, the thing is, like, if you have like x squared plus x plus 1, right? You could factor that and get solutions, right? But if you have a 2, you can have a 2, you can have any number there, you know what I mean? So if we factor it, we kind of have to deal with these fractions because, yeah, you can always multiply through. So let's see, our A is 1, our B is 16/7, and our C is a negative 9/7. So we got negative B plus or minus the square root B squared minus 4AC all over 2A. So we had a negative 16 over 14 plus or minus, all right, 16 times a 16 is a 256, all right, over 49 plus 9 times 4 is 36 over 7. Since we want a common denominator, we can multiply it by 7 over 7. This is all over 2. 16/14 is 8/7 when we reduce it. So 36 times 7 is 252. If we add that to 256, we got a 508 over 49 over 2. All right, the square root of 508 is an ugly number. It's just some random decimal. We could probably reduce it, but since it doesn't come out to be a nice number, we got plus or minus the square root of 508 over 14. So this guy here is 7. And here's our factors. We got an x minus and an x minus. We have to put both of our solutions in here. Negative 8/7 plus the square root of 508 over 14. And negative 8/7 minus the square root of 508 over 14. Now, if we multiply this 7 through, we can only multiply it through on one of them. right? If we multiplied that in, we would have 7x minus negative 8 plus the square root of 508 over 2. We brought that 7 in, right? This one's still going to look the same, though. So that's a factorization using the quadratic formula, right? We can always force it to factor. Okay? So yeah, this guy didn't work. Look at the next one. All right. Our A and our C. 8 times 9 is, what is 8 times 9? 72? Is that right? 9 times 8? Sounds right. So we need our P and our Q to multiply to give us a negative 72. B is 6, so we need them to add, give us a positive 6. So let's see, what can we multiply to give us 72? And the add will give us a 6. One has to be positive, one has to be negative. So divided by 8 and 9. 8 and 9 are too close. All right, 8 times 9 gives us 72, but their difference is only 3, so 6 and 12. If P is positive 12, and Q is negative 6, they multiply to give us negative 72, and they add to give us a positive 6. So we can rewrite this as, rewrite that 6x as a 12x minus 6x. So the first two terms, we could pull out what, a 4x, and we get a 2x plus 6. And then on our second term here, we could pull out a minus 3, and that gives us a 2x. Wait a minute. We'll pull out a 3, 2x, yeah, plus 3, though. What am I doing wrong? 4 times 6 is wrong. I need a 3 there. 4x times a 3 is a 12x. So we have a 4x and a negative 3 both being multiplied by 2x plus 3. So the trick worked on this one. It's interesting they throw in problems that are infactorable like that, you know? Unless I'm making a mistake, I don't think that one was factorable. Not in a pretty way, anyways. So get 26 here. All right, let's try the same trick. We can't factor anything out of here, straight up. We got to try this method again. A times C is 70. So we want two numbers that multiply to give us 70. Our B is 19. So we want our two numbers to add to give us a 19. So let's see, 10 and 7, right? No, they would add to give us 17. What else? 70 divided by 5. Yeah, 14 and a 5, right? P was 14. Q was 5. They multiply to give us 70, and they add to give us 19. So we can rewrite this as this 19 as a 14. No, let's put the 5 first. 5x plus a 14x. Because these are both divisible by 7. These are both divisible by 5. So if we pull a 5x out of the first two terms, we're left with a 2x plus 1. And over here, if we pull a 7 out, we're left with a 2x plus 1 again. So we got a 5x and a 7, both multiplied by 2x plus 1. Questions about that one? My girlfriend's in the hospital right now. She should be giving birth today or tomorrow. She has a scheduled C-section for tomorrow, but we had to go take COVID tests because they won't let you go in, and neither one of us can go in tomorrow for the birth if we don't get our COVID tests today. And we can only get our COVID tests where the hospital says we can. But the place where they say we can get it, they're overbooked, so we can't get in to take her COVID test. So even though she has a scheduled C-section for tomorrow, if there isn't an opening to get her COVID test today, she's going to have to wait till Wednesday, which would put her at 39 and a half weeks with twins.
So you can't go anywhere else to get a COVID?
No, they won't let us go anywhere else. Only the one location where they say it's okay to go.
That's messed.
Yeah, so they
That's kind of
scheduled
messed up, yeah.
section, but they didn't schedule us a COVID test, until it was too late.
Why can't they just do the COVID test at the hospital that you're going to?
Right? That's a good question. Right? Why wasn't this problem factorable? You know what I mean? Why'd they throw that one in there? So yeah, I didn't know about this stuff, this P and Q stuff, when I taught this class yesterday. This is the first time I've taught college algebra. Well, this level of it anyways. And I don't remember learning this. I took this algebra in 8th grade, I think. So I saw this once in the 8th grade, never saw it ever again. I always just used the quadratic formula. And you can see how ugly the quadratic formula is. Even whenever it's factorable, like we did one up here, like this one. Is this it? Yeah, the P and the Q method worked, right? So it was just this. But I didn't know about this stuff yesterday. I just figured that out. And so I was doing all the problems like this. So instead of that simple solution, we did all of this to end up with the same answer. You know what I mean? In the end. So all of that instead of just this. And I did that on every single one of these problems throughout this whole section yesterday. So y'all got lucky that I educated myself since yesterday. I figured there had to be some other way to do this, that they all couldn't be this long. But the other class got a heavy dose of quadratic formula, that's for sure, and a lot of fractions and square roots. So I guess next week with them, I'll redo the class and show them this short method. I'm sure they'll be happy to know they can do these problems in 3 lines instead of 2 pages. I had a class in college, a mathematical physics class, and the teacher gave us 3 problems to work, and he gave us a week. It was a take-home exam, but you know, in mathematical physics at that level, it takes a week to do 3 problems. One of the problems none of us could figure out. So in class, he was going to work it for us. And there's all these different methods that we'd learned. And so we tried each method and we worked together with the teacher as a class, you know. We tried each method and none of them would work out. And we'd do the method, it wouldn't work out. So we'd have to go recheck our work each step of the way to verify that we didn't do anything wrong, to verify that that method wouldn't work. And after we exhausted all the methods, you know, it came out that we couldn't solve that problem, not with what we'd learned in that class. Actually, you couldn't solve it with any method. But although, you know, we had spent a week trying to solve a problem that was unsolvable, and then a whole class period, during that class period, you know, some students were upset that the teacher gave us a problem that we couldn't solve. But what we learned in that class, I learned more in that one class period than I'd learned in probably 2 years of college, you know, by failing. You know, we totally failed to solve the problem. But trying to figure out how to solve it and verifying that it was unsolvable was more informative than just a problem that, you know, here's a method and the method worked, you know. So it's the problems that you can't solve that you learn the most from, you know, if you have the right attitude. All right, let's try this one. Let's try that this AC method again. There's nothing we can pull out of those 3 numbers, right? So our A times our C is a -6. Our B is -5. We're looking for 2 numbers that multiply to give us -6, and they add to give us a -5. So this one looks a lot easier. What if we have like a -6 and a +1, right? They add to give us a -5. They multiply to be -6. So if we rewrite this middle term, this 5x, as a -6x plus an x, then these first 2 terms, if we pull out a 3x, we get an x minus 2, and then we got an x minus 2 here, right? Well, how are we going to factor this? This one's tricky because of its simplicity. How do we factor this out? What we have here is a 1 times x minus 2. See what I mean? So what we have is a 3x plus a 1 times an x minus 2. All right, y'all see that trick? Yeah, I'm going to put this step in explicitly. Yeah, we factored the first one, and then we still got an x minus 2 here. All right, so in order to get it to be factorable, we have to recognize that what this x minus 2 is a 1 times an x minus 2. So we have a 3x and a 1, both being multiplied by an x minus 2. All right, they threw that one in on purpose because of this. Anybody have a question about that? Or was it not resonating?
I think I got it a little bit. I guess I'm just really figuring out how you're plugging it in.
Can you just do another example?
Sure. I'm not sure if how many of them are going to have this particular feature, right?
Yes, sir.
Because we want to have the same thing written twice, right?
Yes, sir.
In parentheses. But when you factor this one, there's no parentheses, right? So we want to rewrite it as a factor. So we rewrite it as a 1 times an x minus 2.
Yes, sir.
So that we have this 3x and a 1 are both being multiplied by an x minus 2. let's look at this one. We can't factor any numbers out. Our A times a C is negative 72. Our B is 1. So we need the two numbers that multiply to be negative 72 that add to give us a 1. See what, 9 and 8, right? P is 9, Q is negative 8. So if we rewrite this X as a 9X minus an 8X, okay? I wrote it in this order because those are both divisible by 3. These are both divisible by 2. So over here, if we pull a 3x out, we get a 4x plus 3, 12x, 9x. Then over here, if we pull out a 2, we get a 4x minus, like plus 3, right? Negative 2 times positive 3 is a negative 6. So both these things are being multiplied by a 4x plus 3. We got a 3x and a minus 2 are both being multiplied by 4x plus 3. All right, any questions about that one?
No, yeah, I think that one I understood a little bit more.
Right? It's just this one up here had that trick, right?
Yes, sir.
There wasn't two terms, right? So we had to rewrite that as a term. See, we
Yes, sir.
see that's the same thing as that, but how do we get it in parentheses?
Yeah.
You
I think I just
multiply it by
understood it
1.
more because you did one when they had a X and a Y, and I understood that more. But I guess since you're doing it kind of like two ways, but you're still using the same variable, that's why I kind of got confused. But now I know now.
Okay. Yeah. This is, it's just like whenever you had like the x squared plus 2x, you know, minus 1. What is A? A is 1, right? We just don't write it. All right, it's the same thing here. You know, what are we multiplying x minus 2 by? We're multiplying it by a 1. All right, so we put that in explicitly.
Yes, sir.
All right, page 40. Factor the binomials completely. All right, this guy doesn't have a b, right? B is 0. What I want you to notice here is that this is the difference of two squares, right? Think about if you solved it. Like, let's say you set it equal to 0 and you solved, right? You get an x squared is 49. You square rooted, you'd have the absolute value of x is 7. So x is a plus or minus 7. That tells you that the solution, or the factor, is an x minus a positive 7 and an x minus a negative 7. All right, so this thing, if we factored it, all right, that's, I just set it equal to 0 to show that we're solving. That tells us that this factors to be an x minus 7 times an x plus 7. All right, notice you have a positive 7x, a negative 7x and a positive 7x, and they cancel out. That's why there's no x term. You might also notice that this is x squared minus 7 squared. This is the difference of two squares. When you have the difference of two squares, it always looks like this. Okay? So the b term, when the b term is gone, right, you always treat it like a difference of two squares, right? The 49, the square root of it is nice. It's just 7, right? But what if this was like a 48 or any other number, you know? When you have an x squared minus k, doesn't matter what k is, right? The factors are going to be an x minus the square root of k and an x plus the square root of k. Right? We got the x squared. The root k times root k gives us the k back, right? And there's a minus. Minus root kx plus root kx. That makes the middle term go away, right? This is the difference of two squares. Right? Yeah, 49 is 7 squared, but it doesn't have to be a pretty number. It doesn't matter what number is there, right? Any number is its square root squared. Let's look at this one. If you notice, this thing is 2x squared and 9 squared. So what this is going to look like, the 2x times a 2x, right? That gives us our 4x squared. And then we have a minus 9 and a plus 9. See, the negative 9 times a positive 9 is a negative 9 squared. You got negative 9 times 2x and a positive 9 times 2x. So the middle terms go away. Okay? So this is the difference of two squares. Should have wrote that up here, right? So we had the x squared. Yeah, I just wrote x, but this is still the difference of two squares. All right, you could probably still use the AC method, right? Let's look and see how well that works, right? A times C is 4 times 81, right? 4 times 81, that's 324. B is 0. So we need a P and a Q that multiply to be 324, but add to give us 0. It's kind of hard to figure out what numbers multiply to be 324, right? And so, right, when it comes to when B is 0, you want to use your square root, your difference of two squares method, okay? So like this one. All right, this is x squared plus 3 squared, right? That's not the difference of two squares, right? But what if we threw in an I in here, right? Let's say if we set this equal to 0, right? And we found our solutions, right? We'd get an x squared is a negative 9. And if we square rooted both sides, we get the absolute value of x. The square root of 9 is 3, but that negative sign gives us an I, right? X is positive negative 3i. So if we're going to factor this, we'd have an x minus 3i and an x plus 3i. All right, so this thing really is the difference of two squares, right? We got x squared plus 9, the difference, right? We need a negative, right? Right, this is the difference of two squares. The 3 squared give us the 9. Remember I squared? I is the square root of minus 1, so I squared is minus 1. So I squared is minus 1, and then the minus is what gives us the plus. So it is the difference of two squares, and we can write it as x minus 3i times an x plus 3i. I know some of y'all are still having difficulty with I here. All right. A lot of y'all
Yeah.
just leave it off. You know, you can't just leave it out of there, right? I is the square root of -1. That means I squared is -1. So whenever you're looking at this, you recognize that 9 is a square. It's 3 squared, right? But this isn't a difference. This is a sum. You want it to be written as the difference of 2 squares. So to get that minus in here, you have to throw that I in, right? The I squared gives you a minus, and that cancels that minus to give you the plus, okay? When you're dealing with solving equations like this, all right, if you end up with that negative in the square root, that's the square root of -1. You got to get that I out there, all right? So, and when you do these, there's always two solutions. There's the positive and the negative, right? So if you check your work, you can always check your work, right? If we got an x times an x, we got an x squared. So we got a plus 3xi, a minus 3xi, then a minus 3i times a positive 3i, right? These two cancel. I got a negative 3 times 3 is 9, and an I squared. The I squared is a -1. All right, so you can always check your work once you factor stuff. All right, you just need to practice with the I's in there. Well, it looks like it's the end of class, so we'll continue this on Monday. All right, so everybody have a good weekend.
Have a good day, sir.
Have a good day. Hopefully you guys get your COVID